I am Phuah and this is my question 4. My new research question for this will be, is there a difference between the observed data frequency and the expected data frequency on the BMI normality of UMS female students? My experimental design will be one variable, which is the BMI normality, using one sample with the sample size of 15 students. BMI normality was obtained from each student. I'm using chi-square goodness of fit test for this because the data collected are nominal data and they are collected from a random sample. This is how the table looks like. And this is the bar plot. My null hypothesis will be the observed data frequency is consistent with the expected data frequency. My alternative hypothesis is the observed data frequency is not consistent with the expected data frequency. I have set the criteria at 0.05 and the degree of freedom will be 1. Due to saying that the majority of female students has a normal BMI, the expected frequency for P, which is the no, will be 0.40, and for Q, which is yes, it will be 0.60. Now I'm going to show my R script. First, I set my working directory, then I read my CSV file, which I saved earlier, then I converted student ID into a vector, and this is the structure of my data, which consists of 15 observations of 2 variables. Then I summarize them. Then I make a table, and this is the result of the table. The table shows that the number of yes will be 2 and the number of no will be 13. Next, I perform the chi-square test, which shows that the x-squared value is 13.611 with a degree of freedom of 1. The p-value is 0.00022249, which is smaller than the critical value 0.05, meaning that the null hypothesis is rejected, and there's the data observed is not consistent with the expected data frequency on the BMI normality of UMS female students. And this is how I make my bar chart using the R calculator. So that's all for my question 4. Thank you.